Today we're going to talk about the use of the Pythagorean theorem. We're going to solve right triangles. We are going to use the Pythagorean theorem in 3 dimensions. In this problem here, we have a parasailer with a tow rope, and it's attached to a boat. The question is asking what type of triangle is formed by the horizontal distance, the vertical height, and the length of the tow rope. It's a right triangle. Okay. One of the things that we have to make sure that we understand is the right angle that's formed from the horizontal and the vertical distances makes it a right triangle. Secondly, we need to remember that the hypotenuse of this right triangle is opposite from the 90-degree angle. You can also know the hypotenuse by the fact that it is the longest side. 75 is longer than 72 and 21. So those are 2 ways you can know that you're looking at the hypotenuse. The legs that are attached to the 90-degree angle, those legs are A and B. It doesn't matter which one you designate as A and which one you designate as B. So when you go to number 2, it says, suppose the wind picks up and the parasailer rises to 50 feet. So the horizontal distance is going to stay 72. He's going to rise to 50, and we need to find out what the new hypotenuse is. So we're going to do 72 feet squared plus 50 feet squared is going to equal the new hypotenuse. $72 squared is 5184, 1,184 feet. 50 squared is 2,500 feet. When we add those together, we get 7,684 feet. In order to find C, we're going to have to take the square root of C squared, and we'll take the square root of 7,684 because what we do to one side of the equation, we have to do to the other. We end up with 87.6 feet, and they want us to round it to the nearest foot. So we're going to say 88 feet is equal to C. Okay, so if we try number 4, it says suppose the tow rope is 300 feet long, which remember is our hypotenuse, the rope, 300 feet long, and the parasailer is 200 feet above the water. So we know that the height is 200 feet, but we don't know the horizontal distance. So we are designating that B. So 300 squared is 90,000. 200 squared is 40,000. We're going to subtract 40,000 from both sides. And when we take the square root of both sides, we're going to find the length of the horizontal distance. If we round the square root of 50,000, we're going to get 224 feet. One of the important things to realize about right triangles is that the right triangle, the hypotenuse is always larger than the legs. So if you see here, we have 18.75, we have 8.75 and 18 feet. They are both shorter than the hypotenuse. However, the sum of the two, 18 plus 8.75, the sum of the legs must be larger than the hypotenuse. So those are two relationships that are good to remember. This is 26.75. So we definitely have a right triangle here because the sum of the legs is larger than the hypotenuse, but the legs are smaller than the hypotenuse. So if I were to say that we had a triangle that is, the sides were 2 feet, 3 feet, and 7 feet. And if we were to ask ourselves, is that a right triangle? We look and we see, okay, so the legs are shorter than the hypotenuse. However, if you take the sum of the legs, that equals 5, and the sum must be larger than the hypotenuse, and that's not true, so this is not a right triangle. Also, neither of the sides can equal the hypotenuse, because if they do, you would have an isosceles triangle where these two sides are the same. So you cannot have a right triangle where one of the legs is equal to the hypotenuse, and the legs of the right triangle must be shorter than the hypotenuse, but their sum must be greater. So if I were to change this scenario, and if I were to say that we have a triangle whose sides are 2, 3, and 4, we have a right triangle. The reason is that the legs are shorter than the hypotenuse of 4. But if I were to add the legs, the sum of the legs is larger than the hypotenuse. And for those two reasons, we are looking at a right triangle. Looking at this particular flagpole, they have listed the points B, A, and C in this plane, okay? So as you can see, when they're listing the Pythagorean theorem, they're using the line segments. AB plus AC, AB squared plus AC squared equals BC squared. This kind of nomenclature is used because we're talking about a three-dimensional situation, and this is what you're going to see a lot in geometry. If they're giving the points of line segments, then you'll see it written that way, but you work the problem out like you normally would. Instead of just having A squared plus B squared equals C squared, this line, the length of AB plus the length squared plus the length of AC squared is going to equal the length of BC squared. It's just a different way of writing it.